Imagine waking up tomorrow morning, walking to your window, and instead of seeing the vast blue ocean that has existed for billions of years, you see nothing but endless, empty basins stretching to the horizon. The Mediterranean Sea, gone. The Pacific Ocean, a massive crater. The Atlantic, a dry valley deeper than the Grand Canyon. What if I told you this isn't just science fiction? What if all the world's oceans simply disappeared overnight? Tonight, as you drift into peaceful sleep, we'll explore this mind-bending scenario together. We'll journey through empty ocean floors, discover hidden underwater mountains taller than Everest, and uncover the mysterious world that lies beneath 71% of our planet's surface, a world no human has ever seen in its entirety. Before we begin this incredible journey into the depths of our imagination, if you're finding comfort in these deep mysteries and sleep stories, consider subscribing to join our community of curious minds who love exploring the unknown as they drift off to sleep. Hit that notification bell, and let's discover together what secrets our planet has been hiding beneath the waves for millions of years. Now, close your eyes, get comfortable, and let's imagine a world without oceans. It's 3:04 a.m. Pacific Standard Time. The ocean waves that have been rhythmically kissing the shores of California for millions of years suddenly stop. Not gradually, not slowly, instantly. As if someone flipped a cosmic switch, every drop of seawater on Earth simply vanishes. The first to notice would be the night shift workers at coastal facilities. Marine biologists monitoring deep sea equipment would see their instruments falling through empty space. Offshore oil rig workers would find themselves standing on platforms suspended above vast, empty chasms. Ships crossing the Pacific would find themselves sitting on dry ocean floor, their hulls resting on sediment that hasn't seen sunlight since the Mesozoic era. But what would this empty ocean floor actually look like? Picture the most alien landscape you can imagine, then multiply that by 1,000. The Mariana Trench, normally hidden under 36,000 feet of crushing water, would reveal itself as a canyon so deep and narrow that it would make the Grand Canyon look like a small crack in the ground. The Mid-Atlantic Ridge, the underwater mountain range that runs down the center of the Atlantic Ocean, would suddenly become visible as the longest mountain range on Earth, longer than the Himalayas, the Rockies, and the Andes combined. These mountains, covered in bizarre rock formations created by volcanic activity and extreme pressure, would stretch for over 40,000 miles across the empty ocean basins. As dawn breaks across this transformed world, the true scale of what's happened would become apparent. Where once there was the gentle curve of the horizon meeting the sea, now there would be edges, sharp, dramatic cliffs dropping into empty basins. The Bering Strait between Alaska and Russia would become a simple land bridge. The English Channel would be a river valley. The Mediterranean Sea would reveal itself as a massive basin filled with ancient cities, shipwrecks, and geological formations that have been hidden for millennia. But perhaps most shocking of all would be the silence. No waves crashing against shores, no seabirds calling over the water, no ship's horns echoing across harbors, just an eerie, profound silence where once there was the constant, comforting sound of the sea. The immediate effects would be catastrophic, but also fascinating. Coastal cities built on harbors would find themselves perched on the edges of enormous canyons. San Francisco Bay would become a valley. New York Harbor would be a deep basin, filled only with air and the occasional bewildered seagull. Imagine walking to the edge of what was once the Pacific Ocean from the California coast. You'd be standing at the rim of a chasm so vast that you couldn't see the other side. The ocean floor, exposed for the first time in Earth's history, would stretch out below you like an alien planet. With the oceans gone, we would finally see the true face of our planet. Earth would no longer be the blue planet. Instead, it would reveal itself as a world of dramatic contrasts, with massive empty basins cutting deep into its surface. The Pacific Ring of Fire would become visible as a massive circle of underwater volcanoes and mountain ranges. Thousands of seamounts, underwater mountains that rise from the ocean floor, but don't quite reach the surface, would suddenly become visible as towering peaks in vast, empty valleys. The Hawaiian Islands would reveal their true nature as just the tips of massive volcanic mountains. Below, what we see as the Hawaiian archipelago, there would be mountain peaks taller than Mount Everest, their bases sitting on what was once the Pacific Ocean floor, over 3 miles below sea level. The Bermuda Triangle area would lose all its mystery as we could finally see the ocean floor that has sparked so many legends. Instead of mysterious disappearances in deep water, we'd see underwater canyons, unusual rock formations, and perhaps the remains of ships and aircraft that contributed to the area's mysterious reputation. The Sargasso Sea, known for its floating seaweed and calm waters, would reveal a relatively flat plain covered in the decomposing remains of centuries of accumulated seaweed. A natural fertilizer deposit, the size of the continental United States. Perhaps most spectacular would be the mid-ocean ridges, the underwater mountain ranges where new ocean floor is constantly being created by volcanic activity. The mid-Atlantic ridge would become the most dramatic mountain range on the visible Earth, with peaks reaching heights of over 13,000 feet above the surrounding ocean floor and stretching from the Arctic Ocean to beyond the southern tip of Africa. These ridges would still be volcanically active, creating an alien landscape of fire and rock where once there was cold, deep water. Imagine looking out over these newly exposed mountain ranges and seeing active lava flows, steam vents, and hot springs scattered across peaks that no human eye has ever seen. The ocean trenches would become the deepest canyons on Earth's surface. The Peru Child Trench would be a narrow canyon running along South America's coast, over 26,000 feet deep. The Japan Trench would cut a dramatic gash along the Pacific coast of Japan, deeper than Mount Everest is tall. But most mysterious of all would be the abyssal plains, the vast, flat areas of the deep ocean floor. These plains, covering more area than all the continents combined, would reveal themselves as endless expanses of fine sediment, accumulated over millions of years. Walking across these plains would be like walking across an alien desert, flat and featureless to the horizon. In some areas, this sediment would be thousands of feet thick, containing the compressed remains of billions of microscopic sea creatures that lived and died over millions of years. This sediment would tell the story of Earth's climate history, layers representing ice ages, warm periods, volcanic eruptions, and even asteroid impacts. As we explore these newly exposed ocean floors, we would discover the remains of one of Earth's most alien ecosystems, the deep sea which covers more than 90% of the space where life exists on our planet, would suddenly be exposed to sunlight for the first time in Earth's history. The first thing we'd notice would be the silence and stillness. Without water to carry sound, the deep ocean floor would be eerily quiet. The bioluminescent light shows that normally illuminate the deep sea, the flashing communications of jellyfish, the glowing lures of anglerfish, the sparkling trails of deep sea plankton, all would be gone, leaving only darkness punctuated by our artificial lights. The creatures that once called these depths home would be scattered across the newly exposed ocean floor like artifacts from an alien world. Giant tube worms, some over 8 feet long, would lie still around what were once hydrothermal vents. These creatures, which lived without sunlight and fed on bacteria that converted chemicals from underwater volcanoes into energy, would be among the strangest sights on this transformed Earth. Near these hydrothermal vents, we'd find the remains of entire ecosystems that existed in complete independence from the sun. Giant clams the size of dinner plates, ghostly white crabs, and bizarre fish with transparent heads and tubular eyes would be scattered around underwater hot springs that would now be shooting steam and hot water directly into the air. The Mariana Trench would reveal its deepest secrets. At its bottom, nearly 7 miles below what was once sea level, we might find the remains of creatures so adapted to extreme pressure that they seem more like living liquid than solid animals. Xenophyophores, single-celled organisms the size of dinner plates, would lie scattered across the trench floor like alien pancakes. Throughout the empty basins, we'd discover the remains of the ocean's vertical migrations. Each night, billions of deep sea creatures rise from the depths to feed near the surface, then descend again before dawn. This daily migration, the largest movement of animals on Earth, would have been interrupted mid-journey, leaving layers of sea creatures at different depths throughout the empty water column. The whale-fall ecosystems would be particularly haunting. These are areas where dead whales sink to the ocean floor and create oases of life. In the deep sea desert, the remains of these ecosystems, specialized bacteria, bone-eating worms, and scavenger crabs that can feed on a single whale carcass for decades, would be scattered around whale skeletons across the abyssal plains. Perhaps most mysterious would be the remains of creatures we've never discovered. Scientists estimate that we've explored less than 5% of the ocean, meaning that 95% of the largest habitat on Earth remains unknown to us. With the oceans gone, we'd suddenly have access to this vast unexplored realm, and the discoveries would be staggering. We might find evidence of deep sea civilizations of octopi, communities of intelligent cephalopods that have been living in the deep ocean trenches, building structures and using tools in ways we never imagined. We might discover massive schools of fish that migrate through underwater canyons we never knew existed, or find the breeding grounds of creatures we thought were extinct. One of the most fascinating aspects of our newly drained world would be the sudden visibility of humanity's maritime history. Scattered across the empty ocean floors would be the remains of every ship that ever sank, every aircraft that went down over water, and every lost cargo that settled into the deep. The Titanic, probably the most famous shipwreck in history, would no longer be a deep sea grave accessible only to specialized submarines. Instead, it would sit on the empty floor of the North Atlantic, 12,500 feet below what was once sea level, finally fully visible for the first time since it sank in 1912. But the Titanic would be just one of millions of shipwrecks now exposed. Along the coast of North Carolina, known as the Graveyard of the Atlantic, thousands of ships from different eras would be visible, from colonial era merchant vessels to World War II submarines, all preserved in the cold, oxygen-poor environment of the deep sea. The Mediterranean Sea basin would reveal itself as one of the world's greatest archaeological treasures. Thousands of years of maritime trade across the Mediterranean would be laid bare. Roman galleys filled with amphorae, Phoenician trading ships loaded with precious goods, and perhaps even ships from civilizations we've lost to history. Some of these Mediterranean wrecks would still contain their cargo, preserved in the cold, dark environment of the sea floor. We might find ships filled with marble statues from ancient Greece, Roman coins by the thousands, or spices and silks from ancient trade routes between Europe and Asia. The Caribbean basin would tell the story of the age of exploration and piracy. Spanish treasure galleons, loaded with gold and silver from the New World, would be scattered across the sea floor. Some of these ships, caught in hurricanes or attacked by pirates, went down with treasures worth billions of dollars in today's money. Off the coast of Florida, we'd find the remains of the 1715 Spanish fleet, 11 ships carrying treasure from the New World back to Spain, all lost in a single hurricane. The gold, silver, and precious gems from these ships would be scattered across the sea floor, no longer hidden beneath tons of sand and water. But it wouldn't just be ancient history revealed. The empty Pacific would show us the remains of World War II in the Pacific theater. Aircraft carriers sunk during the Battle of Midway would be visible on the ocean floor, still containing the aircraft that went down with them. Submarines lost during the war would be scattered across the Pacific basin, some still containing the remains of their crews. The Sargasso Sea area would reveal not just shipwrecks, but also aircraft. This area of the Atlantic, known for its calm waters and floating seaweed, was crossed by many early transatlantic flights. Some aircraft that disappeared over the Atlantic, including perhaps Amelia Earhart's plane, might finally be found among the wrecks, scattered across the sea floor. Each wreck would tell a story, not just of the disaster that sank it, but of the era it came from. Wooden ships from the age of sail would show us how people lived and traded centuries ago. Steel ships from the industrial age would reveal the technology and ambitions of more recent times. And among all these historical treasures, we'd also find more recent losses. Commercial aircraft that went down over water, pleasure boats lost in storms, and fishing vessels that disappeared without a trace would all be visible, finally providing closure to families who lost loved ones at sea. As fascinating as the exposed ocean floors would be, the immediate effects of losing all the world's oceans would plunge Earth into unprecedented crisis. The ocean doesn't just provide water, it's the engine that drives our planet's weather, climate, and life support systems. Within hours, the first effects would be felt around the world. Every coastal city would suddenly find itself perched on the edge of vast chasms. Ports and harbors, the lifelines of global commerce, would become useless overnight. Ships stranded on the newly exposed ocean floor would be impossible to reach or salvage. The weather would begin to change immediately. Without the ocean's moderating influence, temperatures would start to swing to extremes. Coastal areas, which typically have mild climates due to the ocean's thermal mass, would begin experiencing the same temperature variations as continental interiors. San Francisco, normally kept cool by Pacific fog and breezes, would start experiencing desert, like heat during the day and cold nights. But the weather changes would be just the beginning. The ocean drives the global water cycle. Evaporation from the sea surface provides most of the water for rain and snow worldwide. Without this massive source of water vapor, precipitation patterns would collapse within days. Areas that depend on ocean-borne rainfall would become deserts almost overnight. The Pacific Northwest, normally one of the wettest regions in North America, would stop receiving the moisture-laden air masses that create its famous rainforests. The Amazon rainforest, which depends on moisture that evaporates from the Atlantic Ocean, would begin to dry out. Rivers that flow into what were once oceans would become massive waterfalls, plunging over the edges of continental shelves into the empty ocean basins. The Mississippi River would become a waterfall over 600 feet high as it poured over the edge of the continental shelf into the Gulf of Mexico basin. The Colorado River, the Columbia River, the Amazon all would become spectacular waterfalls as they poured into empty basins. But these waterfalls would only last until the rivers themselves began to dry up, as the water cycle that feeds them would be broken. Within weeks, inland lakes and rivers would begin to drop dramatically as evaporation continued, but rainfall largely stopped. The Great Lakes, which contain 20% of the world's fresh surface water, would begin shrinking rapidly without ocean-sourced precipitation to replenish them. Agriculture would face immediate crisis. Most farming regions depend on rainfall patterns driven by ocean evaporation. With these patterns disrupted, crops would begin failing worldwide. The grain belts that feed much of the world's population would turn into dust bowls. But perhaps most critical of all would be the collapse of the oxygen cycle. The ocean's phytoplankton, microscopic plants that float near the surface, produce more than half of the oxygen we breathe. With these organisms gone along with the oceans, atmospheric oxygen levels would begin to drop. It wouldn't happen immediately. There's enough oxygen in the atmosphere to last for some time. But without the ocean's phytoplankton continuously replenishing our oxygen supply, the air would gradually become thinner and less breathable. Let's take an imaginary journey across one of the most fascinating of the empty ocean basins, the Mediterranean Sea. This relatively small sea, which has been the cradle of human civilization for thousands of years, would reveal secrets that have been hidden beneath its waters since before recorded history. Standing on what was once the coast of Spain, looking east across the empty Mediterranean basin, you'd see a landscape more dramatic than the Grand Canyon. The Mediterranean is surprisingly deep, in some places over 17,000 feet below sea level. The entire basin would be visible as a vast, complex canyon system stretching from Spain to Turkey. The Strait of Gibraltar, the narrow passage that connects the Mediterranean to the Atlantic, would become visible as a dramatic cliff face. This underwater cliff, normally hidden beneath the strait, drops over 3,000 feet and would create one of the most spectacular views on the transformed Earth. But the real treasures would be scattered across the Mediterranean floor. This sea has been a highway for human civilization for over 6,000 years. Phoenicians, Greeks, Romans, Arabs, Venetians, and countless other peoples have sailed these waters, and many of their ships now rest on the sea floor. Near the island of Sicily, we might find evidence of one of history's greatest naval battles, the Battle of the Agates Islands in 241 BC, which ended the First Punic War between Rome and Carthage. Saw hundreds of ships clash in these waters. The remains of Carthaginian warships, with their distinctive bronze rams, would be scattered across the sea floor. Off the coast of Turkey, we'd find evidence of even more ancient maritime activity. This area was crossed by Bronze Age traders, carrying tin from the Atlantic to the civilizations of the Eastern Mediterranean. Some of these ships, over 3,000 years old, would still contain their cargo of metal ingots, preserved in the oxygen-free environment of the deep sea. The Eastern Mediterranean would reveal evidence of civilizations we've only heard about in legends. The Sea Peoples, mysterious raiders who attacked the established civilizations around 1200 BC, might have left evidence of their origins on the sea floor. Ships from these unknown peoples, along with their weapons and artifacts, could finally solve one of archaeology's greatest mysteries. But perhaps most exciting would be the possibility of finding evidence of lost civilizations. The Mediterranean basin was dry land during ice ages, when sea levels were much lower. There might be evidence of human settlements that were flooded when the ice melted and sea levels rose, real life Atlantises that have been hidden under thousands of feet of water. Near the Greek islands, we might find underwater cities that were abandoned when rising seas flooded them at the end of the last ice age. These settlements, preserved underwater for over 10,000 years, could contain evidence of advanced civilizations that existed before our recorded history begins. The coast of Egypt would reveal underwater extensions of famous ancient sites. The ancient city of Alexandria, much of which has been underwater since ancient times due to earthquakes and subsidence, would be fully visible for the first time in over 1,000 years. The lost palace of Cleopatra, the ancient lighthouse of Alexandria, one of the 7 wonders of the ancient world, and countless other treasures would be exposed. Moving west across the basin, the coast of southern France and Spain would reveal underwater caves that were once home to prehistoric humans. During ice ages, when the Mediterranean was much smaller, these caves were above water and inhabited by early Europeans. They might contain cave paintings and artifacts from peoples who lived there tens of thousands of years ago. The Pacific Ocean, covering more than 1/3 of Earth's surface, would reveal the most spectacular geological features on our planet. With the water gone, the Pacific Ring of Fire, the chain of volcanoes and earthquake zones that circles the Pacific Basin, would become visible as the most dramatic landscape on Earth. Starting from the coast of California and moving west, you'd first see the underwater mountain ranges that run parallel to the coast. These ranges, created by the same geological forces that formed the coastal mountains of California and Oregon, extend far out into what was the Pacific Basin. The Mendocino Fracture Zone, a massive underwater mountain range that runs west from California, would become visible as a chain of peaks stretching over 2,000 miles into the empty Pacific. This range, created by the movement of tectonic plates, would rival the Rocky Mountains in scale and drama. Further west, the Hawaiian island chain would reveal its true nature. What we see as the Hawaiian Islands are just the tips of massive volcanic mountains that rise from the Pacific floor. With the ocean gone, these mountains would be visible as some of the tallest peaks on Earth, rising over 30,000 feet from the ocean floor, taller than Mount Everest. But the Hawaiian chain wouldn't end with the islands we know. Stretching northwest from the main Hawaiian Islands, we'd see the Emperor Seamount Chain, a series of underwater volcanoes that extends for over 600 miles across the Pacific floor. These seamounts, created as the Pacific Plate moved over the Hawaiian hotspot millions of years ago, would form one of the longest mountain ranges on the visible Earth. Moving further west, we'd encounter the most geologically active region on the planet. The Western Pacific is home to more underwater volcanoes than anywhere else on Earth. With the water gone, we'd see these volcanoes as they really are. Massive peaks rising from the ocean floor, many of them still actively erupting. The Mariana Islands chain would be revealed as the peaks of a massive underwater mountain range. But south of these islands lies the Mariana Trench, the deepest part of any ocean. This trench, over 36,000 feet deep, would become the deepest canyon on the visible Earth, so deep that, if Mount Everest were placed at its bottom, the peak would still be over a mile underwater, if there was still water to be under. At the bottom of the Mariana Trench, we'd find one of the most alien environments on Earth. Here, in what was once the deepest part of the ocean, the pressure was over 1,000 times greater than at sea level. The creatures that lived here were so specialized for this extreme environment that they seem more like aliens than Earth life. The Japan Trench, running along the east coast of Japan, would be visible as another massive canyon, this one over 29,000 feet deep. This trench is where the Pacific Plate slides under the Eurasian Plate, creating the earthquakes and tsunamis that have shaped Japanese history. Along the western edge of the Pacific, we'd see the remains of island arcs, chains of volcanic islands created where oceanic plates collide. The Philippines, Indonesia, and the Aleutian Islands of Alaska would all be revealed as the peaks of massive underwater mountain ranges created by volcanic activity. Perhaps most spectacular would be the mid-ocean ridges, underwater mountain ranges, where new ocean floor is constantly being created. The East Pacific Rise, running up the eastern side of the Pacific Basin, would be visible as a massive mountain range with active volcanoes along its entire length. These ridges would still be volcanically active, creating an alien landscape of lava flows, hot springs, and steam vents. Walking across these newly exposed ridges would be like walking on another planet, with active volcanism creating new rock formations, even as we watched. As the immediate crisis of losing the oceans began to settle, life on Earth would face the ultimate test of adaptation. How would the remaining organisms, those that survived the initial catastrophe, adapt to this dramatically transformed world? The first to adapt would be the microorganisms. Bacteria and archaea, which have survived every mass extinction in Earth's history, would begin colonizing the newly exposed ocean floors. Some of these organisms, particularly those that lived around hydrothermal vents might actually thrive in the new environment. The hot springs and volcanic vents, scattered across the empty ocean basins, would still be active, creating oases of warmth and chemical energy in the cold, empty basins. Around these vents, communities of extremophile bacteria would establish themselves, creating the foundation for new ecosystems, unlike anything that has existed on Earth. Plants would face enormous challenges, but some would find opportunities in the new world. The vast areas of newly exposed ocean floor would represent the largest expansion of available land in Earth's history. Hardy, pioneer plant species would begin to colonize these areas, spreading seeds across the empty basins. The first plants to establish themselves would likely be those adapted to harsh conditions. Species from deserts, Arctic regions, and high mountains. These plants, accustomed to extreme temperature variations and scarce water, would have the best chance of surviving on the exposed ocean floors. Over time, these pioneer species would create soil from the sediments and organic matter scattered across the ocean floors. The layers of marine sediment, rich in nutrients from millions of years of accumulated sea life, would eventually become some of the most fertile soil on Earth. Animals would face the greatest challenges, but some would find new opportunities in the transformed world. Birds, particularly seabirds, would have to completely change their behavior. Many seabirds that once caught fish from the ocean would have to learn to hunt the small animals and insects that would begin to colonize the empty basins. Some birds might actually benefit from the change. With no ocean to cross, migration routes would be dramatically shortened. Birds that once had to fly thousands of miles over open water could now make their journeys over land, stopping to rest and feed along the way. Mammals would face mixed prospects. Marine mammals, whales, dolphins, seals would be gone, but land mammals might find new opportunities. The land bridges created by the drained ocean would allow animals to spread to new continents for the first time in millions of years. Imagine herds of African animals migrating across the dry Mediterranean basin to colonize Europe. Picture North American animals crossing the Bering Land Bridge to establish new populations in Asia. The empty ocean basins would become highways for animal migration on a scale never before seen. Some of the most interesting adaptations might occur in coastal cities and human settlements. Humans, with their technology and adaptability, would likely be among the most successful species in adapting to the new world. Coastal cities would become cliff-top settlements, with dramatic views over the empty ocean basins. New industries would develop around exploring and mining the exposed ocean floors. The vast mineral wealth of the deep sea, manganese nodules, rare earth elements, and precious metals would suddenly become accessible. Agriculture would eventually adapt to the new climate patterns. While many traditional farming regions would become unsuitable for crops, the newly exposed ocean floors would eventually become available for farming. The nutrient-rich sediments of the deep sea could support new types of agriculture. Over generations, humans would adapt their cultures and societies to the new world. Coastal peoples, who had lived with the sea for thousands of years, would develop new traditions and ways of life adapted to their cliff-top existence. New forms of art, literature, and philosophy would emerge from humanity's experience of this transformed world. The loss of the oceans would become a defining event in human culture, shaping how people think about nature, change, and adaptation. With the oceans gone, Earth would effectively have several new continents, the exposed ocean basins. These vast areas, larger than all the current continents combined, would offer unprecedented opportunities for exploration and discovery. The Pacific Basin alone would be larger than all current continents combined. This vast area, stretching from Asia to the Americas, would be a landscape of incredible diversity. The northern Pacific would be a relatively flat plain, covered in deep sediments accumulated over millions of years. Crossing this plain would be like walking across an alien desert. The sediment, made up of the compressed remains of countless marine organisms, would tell the story of Earth's climate over millions of years. Different layers would represent different eras, ice ages, warm periods, volcanic eruptions, and even asteroid impacts. The Central Pacific would be dominated by underwater mountain ranges and volcanic peaks. The Hawaiian chain would be just one of many mountain ranges crossing the basin. Some of these peaks would be so tall that they would create their own weather patterns, with snow-capped summits rising from the dry basin floor. The Southern Pacific would be a landscape of deep trenches and volcanic islands. The Peru-Chile Trench would be a canyon running along the South American coast, deeper than the Grand Canyon and longer than the continental United States. The Atlantic Basin would be dominated by the Mid-Atlantic Ridge, a mountain range running down the center of the basin from the Arctic to the Antarctic. This range, created by the spreading of the ocean floor, would be one of the longest and most dramatic mountain ranges on the visible Earth. The northern Atlantic would be relatively shallow, with the remains of the continental shelves of Europe and North America clearly visible. The Doggerland area, which connected Britain to continental Europe during ice ages, would be exposed as a vast plain dotted with the remains of Ice Age animals and possibly even human settlements. The southern Atlantic would be deeper and more dramatic, with the mid-ocean ridge creating spectacular mountain peaks rising from the basin floor. The Cape Basin, off the coast of South Africa, would be revealed as a massive circular depression, created by the rotation of ocean currents over millions of years. The Indian Ocean Basin would be perhaps the most complex of the new continents. This basin is crossed by several major underwater mountain ranges, creating a landscape of peaks, valleys, and plateaus. The 90 East Ridge would be visible as a massive mountain range, running from the Bay of Bengal to the Antarctic. The Arctic Ocean Basin would be the smallest of the new continents, but perhaps the most interesting historically. This relatively shallow basin would reveal evidence of the land bridges that allowed early humans and animals to migrate between continents during ice ages. Each of these new continents would have its own unique features and opportunities. The sediment plains would be ideal for certain types of agriculture once ecosystems became established. The mountain ranges would contain mineral wealth and offer spectacular scenery. The underwater canyons would become new geographical features rivaling anything on the current continents. Some of these canyons, carved by underwater currents over millions of years, would be deeper and more spectacular than the Grand Canyon. Rivers from the surrounding continents would create new waterfalls and canyon systems, as they flowed into the empty basins. These new river systems would eventually carve new landscapes in the exposed ocean floors, creating valleys, deltas, and floodplains. Over time, these new continents would develop their own climates, ecosystems, and possibly even human civilizations. The vast empty spaces would offer room for expansion that hasn't existed on Earth since the early days of human civilization. The exposure of the ocean floors would represent the greatest scientific opportunity in human history. In one moment, 71% of Earth's surface, previously accessible only through expensive deep sea expeditions, would become available for direct study. Geologists would have unprecedented access to Earth's geological history. The ocean floor contains a more complete record of Earth's geological past than anywhere on land. Unlike continental rocks, which are constantly being weathered and eroded, the ocean floor preserves layers of sediment that record Earth's history in incredible detail. We would finally be able to study the complete record of Earth's magnetic field reversals. As new ocean floor is created at mid-ocean ridges, it records the direction of Earth's magnetic field at the time. With the entire ocean floor exposed, we could read Earth's magnetic history like a book, understanding how and why the magnetic field changes over time. The sediment layers would reveal the complete history of Earth's climate. Different types of sediment are deposited during different climate conditions, and the microscopic fossils preserved in these sediments would tell us about ocean temperatures, ice coverage, and atmospheric conditions going back millions of years. We would discover evidence of asteroid impacts that we never knew occurred. Large asteroid impacts create distinctive layers in ocean sediments, and with the entire ocean floor exposed, we might find evidence of impacts that left no trace on land. Paleontologists would have access to fossil beds that dwarf anything found on land. The ocean floor contains the remains of countless marine organisms that lived and died over hundreds of millions of years. These fossils would fill in gaps in our understanding of evolution and reveal species that we never knew existed. The deep sea fossil record would be particularly valuable because it's more complete than the land fossil record. On land, fossils are often destroyed by erosion or geological activity. But in the deep ocean, they can be preserved for millions of years. Marine biologists would face the monumental task of cataloging the remains of deep sea ecosystems. We've only discovered a fraction of the species that live in the deep ocean, and suddenly we'd have access to all of them. The hydrothermal vent ecosystems would be particularly important to study. These ecosystems, which exist without sunlight and are based on chemosynthesis rather than photosynthesis, might give us clues about how life could exist on other planets. Archaeologists would have access to the most complete record of human maritime history ever available. Every ship that ever sank, every aircraft that went down over water, and every object that was ever lost at sea would suddenly be accessible. The archaeological treasures would be staggering. We would find evidence of trading routes and maritime cultures that we only knew from written records. We might discover civilizations that were completely unknown to history. The shipwrecks alone would revolutionize our understanding of historical technology, trade, and culture. Ships are time capsules that preserve the technology, goods, and even the people of their era. With millions of shipwrecks suddenly accessible, we would have an unprecedented window into human history. Climatologists would gain access to the most complete record of Earth's climate history. The ocean is the primary driver of Earth's climate system, and the sediments on the ocean floor contain a detailed record of how climate has changed over millions of years. This climate record would be invaluable for understanding how climate systems work and how they might change in the future. We could study past periods of rapid climate change and understand what caused them and how ecosystems responded. Perhaps most importantly, we would finally understand the full scope of life on Earth. The deep ocean is the largest habitat on our planet, but it's also the least explored. With the oceans gone, we would suddenly have access to ecosystems that we barely knew existed. The discoveries would reshape our understanding of biology, evolution, and the limits of life on Earth. We might find forms of life that challenge our basic assumptions about what life is and how it can exist. One of the most tantalizing possibilities of our drained world would be the search for lost civilizations. Throughout human history, rising and falling sea levels have alternately exposed and submerged vast areas of the continental shelves. What secrets might be hidden beneath the waters? During the last ice age, which ended about 12,000 years ago, sea levels were 400 feet lower than they are today. This means that vast areas of what is now ocean floor were once dry land that could have supported human civilizations. The Bering Land Bridge, which connected Asia and North America, would be exposed as a vast plain. This bridge wasn't just a narrow crossing. It was a subcontinent the size of Alaska, dry for thousands of years during the Ice Age. Early humans didn't just cross this bridge quickly. They lived on it for generations. Archaeological evidence of these Beringian peoples might be scattered across the floor of the Bering Sea. We might find the remains of camps, hunting sites, and even permanent settlements of the peoples who first discovered the Americas. But Beringia is just the beginning. The continental shelves around the world were once dry land, and humans were already spreading around the globe when sea levels were low. Off the coast of every continent, there might be evidence of Ice Age civilizations. The North Sea, between Britain and Europe, would reveal Doggerland, a vast plain that was home to hunter-gatherer peoples for thousands of years. This lost landscape, sometimes called Britain's Atlantis, was submerged when sea levels rose at the end of the Ice Age. Doggerland wasn't just empty land. It was a rich landscape of rivers, forests, and lakes that supported large populations of both animals and humans. Archaeological sites scattered across this submerged plain would tell us about the peoples who lived in northern Europe before agriculture. Off the coast of India, the continental shelf extends far into what is now the Indian Ocean. During ice ages, this area was dry land that could have supported the early civilizations of the subcontinent. Some historians believe that references to lost lands in ancient Indian texts might refer to areas that are now underwater. The Persian Gulf was almost entirely dry land during the Ice Age. This fertile plain, watered by the Tigris and Euphrates rivers, might have been the location of some of humanity's earliest agricultural settlements. These settlements could be the real world basis for the Garden of Eden stories found in many Middle Eastern religions. Archaeological sites in the Persian Gulf basin might revolutionize our understanding of the development of agriculture and civilization. We might find evidence of farming communities that predate the earliest known agricultural sites by thousands of years. Off the coast of Southeast Asia, vast areas of the continental shelf were exposed during ice ages. The entire area between mainland Asia and Australia was a landscape of islands and plains, sometimes called Sunderland. Early humans island hopped across this region to reach Australia over 50,000 years ago. The remains of their campsites, boat building areas, and island settlements might be scattered across the floors of the South China Sea and Indonesian seas. These sites would provide evidence of some of humanity's earliest seafaring technology. Perhaps most intriguingly, we might find evidence of more advanced civilizations that were lost to rising seas. Ancient texts from around the world contain references to great floods and lost lands. While these stories were often dismissed as myths, they might contain memories of real places that were submerged when Ice Age glaciers melted. The Mediterranean basin might contain evidence of advanced civilizations that existed before the sea refilled after the last ice age. Some geologists believe that the Mediterranean was a dry basin during ice ages, connected to the Atlantic only by a narrow channel or completely cut off. If this is true, the Mediterranean basin might have been home to advanced civilizations that developed in isolation, only to be destroyed when rising Atlantic waters broke through the Gibraltar barrier and refilled the basin in a massive flood. This flood, which some scientists call the Zanclean flood, might have been catastrophic enough to destroy entire civilizations and create the flood legends found in cultures around the Mediterranean. The Black Sea tells a similar story. This sea was once a much smaller freshwater lake, but it was catastrophically flooded when rising Mediterranean waters broke through the Bosphorus around 500 years ago. This flood might be the basis for the flood stories in Mesopotamian religions, including the story of Noah. Archaeological sites around the edges of the Black Sea basin might contain evidence of the civilizations that were destroyed in this flood. These sites could provide direct evidence of the historical events that inspired some of humanity's most enduring religious stories. As our journey through this transformed world comes to an end, we find ourselves contemplating a planet that would be both familiar and utterly alien. Earth without oceans would still be our home, but it would be a home transformed beyond recognition. The most profound change would be the silence. Those of us who have lived with the constant, comforting sound of waves on shores would find a world eerily quiet. No waves, no seabirds calling over water, no foghorns or ship bells. Just the wind across empty basins and the sound of rivers falling into vast canyons. But in this silence, we would hear new sounds. The active volcanism of the mid-ocean ridges would create a constant background of geological activity. Steam vents would whistle across the empty basins. Underground rivers, following paths carved by ancient ocean currents, would bubble up through the sediment. The night sky would be different too. Without the ocean's water vapor creating clouds and weather patterns, many areas would have clearer skies than we've ever seen. The empty ocean basins, far from city lights, would offer some of the best stargazing locations on Earth. From these dark ocean floors, we could see the Milky Way in all its glory, stretching across skies unmarred by light pollution or ocean-generated clouds. Astronomers would establish observatories in the deepest parts of the empty basins, where the thin air and stable conditions would allow for unprecedented views of the universe. The cultural changes would be profound. Coastal peoples, who had defined themselves by their relationship with the sea, would have to create new identities. Fishing communities would become archaeological communities, exploring the treasures of the sea floor. Port cities would become gateway cities to the new continents of the empty ocean basins. Languages would change too. All the words we have for ocean phenomena, waves, tides, currents, storms at sea, would become historical terms, used only to describe the past or to talk about the lakes and rivers that would remain. New words would emerge to describe the features of the empty ocean world. We would need terms for the different types of ocean floor terrain, for the weather patterns that would develop in the deep basins, for the new ecosystems that would eventually emerge. Art and literature would be transformed. The ocean has inspired countless works of art, literature, and music throughout human history. Artists would need to find new sources of inspiration in the stark beauty of empty ocean floors, and exposed underwater mountain ranges. But perhaps they would find even greater inspiration in the drama of this transformed landscape. The mid-ocean ridges would offer scenery more spectacular than any mountain range on the current continents. The deep trenches would be canyons of unprecedented scale and beauty. Philosophy and religion would grapple with the meaning of such a transformation. What would it mean for humanity to lose something so fundamental to our planet as the oceans? How would our understanding of our place in the universe change when faced with such dramatic evidence of our world's fragility? Some might see it as a disaster, the end of the world as we know it. Others might see it as an opportunity, a chance for humanity to start fresh on a transformed planet with vast new territories to explore and settle. Environmental movements would likely emerge focused on preserving what remained of the old world while responsibly exploring the new. The exposed ocean floors would be pristine environments, untouched by human activity, and there would be intense debate about how they should be used. Education would be revolutionized. Children would grow up learning about oceans as historical features like dinosaurs or ice ages. They would study marine biology as paleontology, learning about creatures that once lived in a water world that no longer existed. But they would also learn about new possibilities. The empty ocean basins would offer opportunities for human settlement and development that haven't existed since the early days of human civilization. These children might be the first generation to establish permanent communities on the floors of empty ocean basins. Science would advance rapidly as researchers gained access to 71% of Earth's surface that had previously been largely inaccessible. Every field of study would be revolutionized by the wealth of new data and specimens available. The study of life itself would be transformed. The deep sea ecosystems, adapted to conditions unlike anywhere else on Earth, would provide insights into the fundamental nature of life and its limits. Technology would advance to meet the challenges of this new world. New forms of transportation would be needed to cross the vast empty basins. New types of agriculture would be developed to work with ocean floor sediments. New energy sources would be found in the geothermal activity of the exposed mid-ocean ridges. But perhaps most importantly, humanity would learn about resilience and adaptation. The loss of the oceans would be the greatest challenge our species has ever faced, but it would also be an opportunity to demonstrate our ability to survive and thrive in the face of overwhelming change. As we drift off to sleep, we can imagine this transformed world not as a disaster, but as an adventure. A world where every day would bring new discoveries, where vast new territories would be waiting to be explored, where humanity would have the chance to write a new chapter in the story of our relationship with our planet. In this ocean-free world, we would learn that home isn't just the familiar blue marble we see from space. Home is wherever life finds a way to survive and thrive. Wherever conscious beings gather to contemplate the universe and their place in it. And perhaps most comfortingly of all, we would learn that even in a world transformed beyond recognition, the human capacity for wonder, curiosity, and adaptation would remain unchanged. We would still look up at the stars and dream of what lies beyond. We would still tell stories by firelight, now gathered around geothermal vents in empty ocean basins. We would still find beauty in our world, even if that beauty took forms we had never imagined. The ocean-free Earth would be different, challenging, and strange, but it would still be home. And as we've learned throughout human history, home is not just where we come from. It's where we make our lives, adapt to our circumstances, and continue the eternal human journey of discovery and understanding. As we conclude our journey through this transformed world, remember that even the most dramatic changes begin with simple curiosity, the same curiosity that brought you here tonight to explore impossible scenarios and hidden mysteries. If these deep explorations into the unknown help you drift into peaceful sleep, and if you'd like to join our community of fellow explorers who find comfort in contemplating the vast mysteries of our universe, consider subscribing and hitting that notification bell. Together, we'll continue exploring the hidden corners of our imagination and the secret places our world keeps tucked away beneath waves, behind mountains, and beyond the stars. Sweet dreams, fellow explorer. May your rest be filled with visions of empty ocean floors and underwater mountains reaching toward alien skies. Until our next journey into the impossible, sleep well.